In modern war, one of the deadliest threats may not be a fighter jet, a tank, or even a missile. It may be a cheap drone, flying low, fast, and just long enough to find a target. And in March 2026, during Operation Skyfall in Germany, the US Army used one of its most recognizable attack helicopters to show it is adapting to exactly that threat. At Grafenwoehr, AH-64 Apache crews from the 159 Attack Battalion detected, tracked, and defeated simulated drone targets in a counter-UAS exercise, designed to test how Army aviation can survive and fight in a battle space increasingly shaped by unmanned systems. This was not just another training event. According to the US Army footage, Operation Skyfall was designed to advance the Eastern Flank defense line concept through demonstrated counter-unmanned aerial systems capabilities. The exercise focused on refining tactics, integrating modern technologies, and validating new approaches to counter-UAS employment. In other words, this was a test of whether a helicopter built for tank killing and close combat can also become a relevant weapon against the small aerial threats now saturating modern battlefields. And that is what makes Skyfall important. Across recent conflicts, drones have changed the tempo of war. Small systems now scout artillery targets, harass ground units, overwhelm air defenses, and force expensive platforms to react to low-cost threats. The Army Recognition Report on the exercise explicitly links the Apache's new role to the spread of cheap drones observed in Ukraine and along NATO's eastern flank, arguing that Army aviation is being pushed into a critical new phase, where radar, electro-optical sensors, and targeting systems must be used not only against armored or ground targets, but also against small unmanned aircraft. What Skyfall demonstrated is that adaptation is no longer optional. Military aircraft designed in an earlier era cannot remain effective by doing only what they were built to do decades ago. They have to evolve. And for the Apache, that evolution is especially significant because this helicopter still sits at the center of US Army attack aviation. Boeing describes the Apache as the backbone of the Army's attack helicopter fleet. And the current AH-64 model is being kept in production into the 2030s, with service life expected well into the 2060s. That only makes sense if the aircraft can absorb new roles, new sensors, new software, and new ways of fighting. During Operation Skyfall, the AH-64 crews from the 159 Attack Battalion operated at Germany's Grafenwoehr training area, where they worked through a scenario centered on simulated drone threats. The significance is not simply that the Apache can shoot at drones. The real message is that the aircraft can be inserted into a wider counter-drone kill chain. Detection, classification, prioritization, handoff, and engagement are what matter. The AH-64 integrates advanced sensors, networking, and real-time data sharing to enable the detection and prioritization of multiple targets, while also giving the helicopter the ability to command unmanned aerial vehicles to extend its own sensor reach. That means the Apache is evolving from a traditional attack helicopter into something closer to a networked node in a larger air-ground fight. To understand why this matters, it helps to step back and look at what the AH-64 actually is. The Apache family entered US Army service with the AH-64A in 1984. Over the following decades, it became one of the most recognizable and extensively used attack helicopter families in the world. Boeing says the Apache fleet has accumulated more than 5.3 million flight hours, including more than 1.3 million in combat, and that more than 1,300 aircraft are in operation globally. The AH-64 is the latest major evolution of that line, built not as a clean sheet replacement, but as a heavily modernized and digitally connected version of a platform already proven across multiple theaters. For the US Army specifically, the first AH-64 was fielded in January 2013, and the type reached initial operating capability in November of that year. That makes the AH-64 a relatively recent variant in service terms, even though it belongs to a helicopter lineage that dates back more than 4 decades. In practical terms, the Army has spent the last decade turning the Apache from a Cold War anti-armor attack helicopter into a far more flexible system, capable of operating across high-intensity, networked, and increasingly drone-saturated battlefields. Technically, the AH-64E remains a twin-engine, tandem-seat, four-blade attack helicopter, but the modernized version adds a major leap in connectivity, sensing, and system architecture. The Army describes the AH-64D/E as equipped with an M230 30mm cannon, Hydra 72.75-inch rockets, and Hellfire missiles, including laser-guided and radio frequency variants. The E model was designed with an open systems architecture, so it can keep integrating updated communications, navigation, sensor, and weapon systems over time. That open architecture matters because today's counter-drone mission is as much about software and sensor fusion as it is about raw firepower. The AH-64E's mission systems are optimized for precision engagement, situational awareness, and networked operations. In combat terms, that means Apache crews are no longer limited to what they can directly see out of the cockpit. They are increasingly tied into a larger tactical network, receiving and sharing targeting data, while building a more complete picture of the battle space. Its sensors are a central part of that story. Boeing describes the Apache's advanced sensor and targeting suite as enabling detection, classification, and prioritization of multiple targets. Lockheed Martin, which supplies Apache fire control systems, says the Longbow and APG-78 fire control radar provides automatic target detection, location, classification, and prioritization, with version 6 enhancements adding modes and range improvements against land, air, and sea targets. The weapons suite also makes the Apache adaptable. In its standard role, the helicopter can carry combinations of Hellfire missiles, Hydra rockets, and 30mm ammunition. Recent Army reporting on Apache counter-UAS demonstrations in 2025 showed the platform being used against drones with radar and laser-guided missiles, laser-guided rockets, and the 30mm gun, while leveraging both radar and EO/IR sensors. That is important because it suggests the Apache is not being pushed into a single narrow anti-drone method. Instead, it is becoming a multi-option interceptor, able to match different engagement tools to different drone types, ranges, and tactical conditions. The helicopter is already an established combat platform, integrated with ground forces, widely fielded, and familiar to commanders. So when the Army gives it a counter-drone role, it is not introducing a completely new system that needs to be inserted from scratch into force structure. It is expanding the mission set of an existing, fielded, crewed platform. So, what is the larger impact of Skyfall? On a battlefield increasingly crowded with drones, the U.S. Army is signaling that the Apache will not remain locked in its traditional role. It is being recast as part of a layered answer to unmanned threats, combining mobility, radar, optics, precision weapons, and digital connectivity. Exercises like Skyfall matter because they show the Army trying to build tactics before the next crisis, not after it. And in Europe, where NATO planners are watching the lessons of Ukraine closely, that carries immediate relevance, but the challenge is not solved. Drone systems are evolving continuously. They are getting cheaper, more numerous, more autonomous, and more diverse in size and profile. For the AH-64E to keep pace, it will need constant upgrades in sensors, software, networking, and low-cost engagement options. The helicopter's future value may depend less on how many missiles it can carry, and more on how quickly it can identify new types of aerial threats, share that data across the force, and engage them with the right weapon at the right cost. Boeing's emphasis on open systems, launched effects, and greater interoperability points in exactly that direction. In the end, Operation Skyfall in Germany was about more than one exercise. It was a glimpse of how an iconic helicopter is being reshaped for a battlefield where the sky is no longer dominated only by aircraft and missiles, but by swarms of small unmanned systems. And if the Apache can continue to evolve fast enough, it may remain not just relevant, but central in the next era of air-ground combat.